Okay, everybody, it looks like it's time to go over some of those Canvas questions on alternating series. So here we go. I skipped questions 1 and 2. They're pretty much just definitions. You can get them from the videos, or you can look them up, but they really are just definitions of what alternating and what absolute versus conditional convergence are. So we're going to go to number 3. Question 3 said, what are the first 3 terms of the harmonic series and does it converge? This again, almost definitional. The harmonic series is simply 1 plus a half plus a third plus a fourth and so on. And it is a non-convergent, it's a divergent series. There are proofs of that. You can look those up, but simply know that the harmonic series will diverge. Which brings us to question 4, which asks for the first 4 terms of the alternating harmonic. Alternating harmonic is simply the harmonic with alternating signs. So it's 1 minus 1/2 plus 1/3 and minus 1/4 of the first 4 terms. And that would continue for an infinite alternating harmonic, and it converges. Why does it converge? Well, again, if we go back to the definition of a convergent alternating series, we need to have terms whose limit is 0. And we know that if we're looking at 1 over n, the limit is off to 0 as n approaches infinity. We also have to have each term getting smaller than the next, and that's what's going on here as well, we can tell. So we've got the convergence, and there we go. Let's look at number 5. Question 5 says, if you approximate the sum of an infinite alternating series with only the first 6 terms, so kind of looking at a sum only up to 6, if we're going to use this to approximate the error in the partial sum, in other words, how far would we be from the real infinite sum, is simply the next term. That's it. There's an explanation of why that's true in another video I just posted earlier today, but it's the next term. So if we're using 6 terms, then the 7th term would be the most that we would be off of the true sum. And that's the only answer you can give is a sub 7. Question number 6. Looking at a geometric series, again, they're telling us it's geometric. You could figure it out by recognizing that each time we're multiplying the denominator by 2 and by a negative. So r is going to be negative 1/2 in this case. It says geometric. That's a useful thing to get, by the way, as long as we're here. First term, 3/4. Now, if we use the first 6 terms, what's the maximum error to approximate the infinite sum? Again, what we're looking for here is, for part A, it's simply the 7th term. They're giving us the first 4 terms. We need to get to the 7th. It says no calculator. Shouldn't be too bad. We're at 3/4 minus 3/8 plus 3/16 minus 3/32. So we keep going. We're going to add 3, and we're doubling denominators. Subtract 3, 128. What are we up to? 1, 2, 3, 4, 5. There's 6 terms. The 7th term would be 3 over 256. This would be the error in doing this calculation. Part B. What is S sub 6? Again, we could do this without a calculator. We're simply adding up these 6 terms right here. And if you add these all up, the sum is 3 over 256. Not a big deal. We can check that out. Sum of the first 6 terms. Next up is looking at part B here, or the rest of part B. What's the infinite sum? Well, the infinite sum is the first term over 1 minus r. That's our geometric series formula. In this case, that's 3/4 over 1 minus the negative half. So we're looking at 3/4 over 1 plus 1/2. So that's 3/4 over 3/2. Bring this up, becomes 2/3. And when we multiply through, we get 2/4 or 1/2. So the sum is actually 1/2. Finally, we're just asked to show that these differ, these being the real sum compared against the approximate sum. This is the sum only from k equals 1 to 6. So if we compare these two numbers, subtract them, the difference there should be less. Okay, there we go. Did anybody catch my mistake? Because it's right here. Because the sum of those terms, which I was looking, 128 is 63 divided by 128. I wrote this number down a second time. So the sum is actually 63 over 128. Hey, just like when we're in class, I get to make mistakes. And when you subtract these, the difference is less than the error that we had calculated. So it does work, especially when you do it correctly. Let's take a look at the last one here, number 7. Number 7 says, for this particular series here, they give us the formula for the series. If we use it for 5 terms, what's the maximum error? The maximum error is going to be the 6th term. So a sub 6, in this case, that's -1 to the 6 plus 1 divided by 6 factorial. Now, this is going to be a negative number, but we know that we're looking at error, so it's really the absolute value of this. So it's the absolute value here, and that's 1 over 6 factorial, or 1 over 720. This is a number we can get nice and exact, no reason to decimal approximate that. And that takes care of those 7 questions. Sorry about the little error there in number 6. Look for a video or so. The next posting on Canvas will be about the ratio test. That's the last of the tests for convergence that we're going to need to know. Look for that probably tomorrow. And that's it for now.